Yeah, so we were on differentiability, discussing differentiation and the rules of differentiation. Right? So we have discussed, first of all, some basic formulae. It can be based on just a minute. Yeah, so it can be based on either the formula includes basically the differentiation of algebraic functions, exponential functions, constant functions, right? And after that, logarithmic functions and some trigonometric functions, right? Then the rules of differentiation included. First rule was if a constant is being multiplied or divided, right? If a constant is being multiplied or divided with a function, then you take that constant out and you differentiate just simply the function. So, and I have also showed you some examples for all of these. Then second was term by term differentiation. If there are two or multiple terms, two or more than two terms, which are being added or subtracted with each other, and we want to differentiate the whole expression, then we just simply differentiate term by term. We differentiate each term and put the sign as usual given in the question, right? Then after that, we have studied about product rule. Product rule was if two functions are being multiplied, then how do we differentiate both of them together, right? And we understood it with some examples as well. And then there was last rule we have studied about quotient rule. Quotient rule was when two functions are divided, right? So how do we apply the formula of differentiation to these two functions, which are basically dividing one function? We are basically dividing one function with another function, right? Now, the last rule of this series is the most important rule, first of all, and this will be used the most as well. Okay, so before heading out for the last rule, we can just simply solve this last question given in the class. E to the power x sin x minus 10x upon ln x plus 4 sin x sec x minus x square upon 2 to the power x, right? So we can solve this one. And can you tell me the answer for this? You have to basically tell me the differentiation of x upon ln x. One expression is this, and then one expression is x square upon 2 to the power x. You have left this question in the last class for you guys to practice. Can someone complete this now? This all two parts, this one and this one. Anyone? Okay. In that case, we can start with this x upon ln x. So this, oh, sorry. So here two functions are given, x and ln x, which are in divide. So we will have to apply quotient rule here. Quotient rule says that, first of all, square the denominator. So ln x whole square. Now remember that ln x whole square will not be written like this, ln square x or ln x square. If you are writing ln x whole square, then you will have to basically represent it like this. The sensitivity of the pen is too much for me to handle because I've changed my this tab today, so it will take some time to adjust, but yeah, I'll do that. So applying x upon ln x, applying the quotient rule to x upon ln x, first we will square the denominator. So in that case, we will write ln x whole square. Then differentiation of first priority function, which is numerator. So differentiation of x will be 1 and your denominator as it is, minus numerator as it is and differentiation of denominator, which will be 1 by x in this case. So your 10x upon ln x will give you 10 into 1 into ln x minus x into 1 upon x divided by ln x whole square. And we have already calculated 4 sin x into sec x. That should be 4 sec square x, the differentiation. Okay, here we have to write f dash x. And then minus x square upon 2 to the power x will be So again, we'll have to apply quotient rule. We'll first square the denominator. So denominator whole square will be 2 to the power x whole square. Right? And we can multiply x and 2, this x and 2 here. And multiply both of them. Okay? So it can further be written as 2 to the power 2x. Or instead of that, we can also write it as 4 to the power x. Right? So we'll simplify that expression. Yeah, but coming to the formula, application of formula. So after that, we will differentiate the numerator, which is 2x in this case, because we are differentiating x square, into denominator as it is, which is 2 to the power x, minus numerator as it is, differentiate the denominator, which would be 2 to the power x ln 2. 2 to the power x ln 2. So this can be further written as e to the power x sin x plus cos x minus 10 times. This would get simplified to ln x. 1 into ln x is ln x minus 1. Right? Because x into 1 upon x is 1. Divided by ln x whole square. Plus 4x square x. Now this would be what? Okay, so you can take 2 to the power x common from the numerator. Both the terms contain 2 to the power x, right? So you can take the 2 to the power x common. So it will be something like that. 2x minus x square ln 2. If you take 2 to the power x common, here you will be left with 2x minus x square ln 2. You can also take 1x common, if you see. You can also take 1x common. So you'll be left with 2 minus x ln 2, and then there will be x here divided by 2 to the power x whole square.
Sir, here for 4x square x there is plus, right?
Sorry.
After 4x square x there is plus, right?
This is 2 to the power x into x. We have taken two things common from these two terms. One, we can take 2 to the power x common because both the terms contain 2 to the power x, and also both term contains x. So we can take 1x common. So this is basically 4x square x into 2 to the power x into x. And then in whole, 2 minus x ln 2 divided by 2 to the power x whole square. Now see, the differentiation part got over in this step, but still we are simplifying this because we have to give the simplified answer, right? So it will be e to the power x sin x plus cos x. And we can write it more in a more fancy way if we distribute ln x whole square to both the terms. So what we can do is minus, if you distribute ln x whole square with this ln x, then you will be left with 1 ln x in the denominator, right? So this will be something like this, minus 10 upon ln x, right? Then minus 10 into minus 1, this will be plus 10 divided by ln x whole square. Plus, okay, my bad. This has to, I mean, we have to apply x plus sign. 4x square x is the differentiation of this term, 4 sin x into sec x. So we have to put a plus here. Then you can take 2 to the power x into x common from these two terms. So this can be further written as 4x square x plus 1 2 to the power x will cancel out second 2 to the power x. I mean, you can cancel this with square. So you will be left with x into 2 minus x ln 2 divided by 2 to the power x. This will be a final answer for the differentiation part. So you'll have to two things we should notice from here is one, that whatever function will be given to you will either use any of these formula, either two function will be multiplied, or it can be a combination of some functions in multiplication and addition. So you'll have to apply the appropriate rule as described. And second thing is that you have to give the simplified version of the answer. Okay. Please note this down if somebody has it. And ask me your doubts if you have. Okay, can you move forward? If somebody is writing, just raise your hand. Cool. So now starting with the most important rule, which is chain rule. Now basically chain rule depends on the composition of function. Chain rule describes you when there are composition of functions involved, then how do you differentiate those functions, right? For example, I'll tell you guys what I mean actually with this sentence. Let's say we have this function fx, which is equal to sine x, and we have been asked to find out f dash x. In that case, we know how do we differentiate sine x. There is a formula given for sine x, right? So we will differentiate sine x directly, and the differentiation will be cos x. Now, if you multiply 4 sine x, that is okay, because a constant is being multiplied with a function, and the differentiation of function we know. So we will what we will do, we will just take that constant outside, and we will differentiate the function as usually we were doing. Right? But what happens is, how do the differentiation of this function change when instead of multiplying 4 to the outside of this function, if I multiply 4 like this, if I make x sine 4x, or even better is a situation where you might keep changing this x. So instead of x right now, I'm using sine x square. This is sine of x square, right? Now it is not sine x. So the relationship between x and y, or the relationship between your dependent variable and independent variable, changes in this case. You don't have a formula for sine, differentiation of sine of x square. You have a formula for sine x. So there can be, and there are some more examples to it. We do have a lot of examples. For example, 2 to the power sine x. So you have a formula for 2 to the power x, exponential function. But you don't have a formula for 2 to the power sine x. Right? So these are known as composition of functions, when we are basically mixing two functions. Like in hx, in the third function, we have mixed exponential function with trigonometric function, right? So what happens in these cases is, we have to apply chain rule. And how do we apply chain rule? So, okay, let's start with this. So for example, we have a function which is like this. Let's say we have a function hx, which is a combination of two functions, f and g, but something like this, f of gx. I think you all have studied about composition of function in class 11. If not, then I'll introduce this concept very easily. and this is not a big thing to learn. So for example, we have a function fx is equals to sin x, okay, and then we have a function gx is equals to log x. Okay. Now, if I want to write fog x is basically f inside gx. So instead of x, we have replaced x with gx in fx. For example, what I'm saying is, let's say fx is sin x, right? So if I want to write fy, what will be that? Sin y. If I want to write f20, that will be sin 20, right? So now if I'm writing f of gx, it means that wherever x is involved in fx, you have to replace that x with gx. So your original function fx was sin x. Now that sin x becomes sin of gx, because instead of x, you have replaced gx in this function f. And now you can even put the value of the function gx, and in that case, this f over gx function will be known as, or can be seen as, sine of log x. That is how composition of function works. So let's say in this case, I want to write g over fx. That is how we read this expression, g over fx. And g over fx money, you can write it like this. You can even continue this chain for a longer time, however time you want it, right? So g over fx will be replacing x with fx, in gx. Whatever is the outside function, you'll start taking the priorities of function from left side. So the leftmost function will be on the outside region, right? And then similarly, you will reach to the inside of the function. So if we are writing g over fx, it means that the original function is g, and we have to replace x with fx in gx. So we can write it as log of, so gx was log x. If I want to write g over fx, that will be log of fx, right? And now I can put the value of fx. Fx is basically sin x. So the function is log sin x. This is what we call composition of function. And through this composition of function, we can actually create a lot of varieties for the function. Right? And while creating these, this is very important to know how to differentiate this composition of functions, because a lot of functions you will encounter on a daily basis will be composition of function type. So how to differentiate composition of functions, or basically these chain kind of functions, is this chain rule describes exactly that. So while writing this rule, now let's understand how this rule works. So let's say we have a function hx, which is a combination, or which is a composition of two functions, f over gx. So how do we differentiate this? So we start differentiating from the left hand side, that is, which is the function, whichever function is the outside will be differentiated first. So if I want to write h dash x, this will work in this way. First, we will differentiate the leftmost function. So it will be written as f dash, and whatever is inside this function, that will remain as it is, f dash gx. Whatever is inside that function, whatever input of that first function is given, that will remain as it is, and we will only differentiate the first function, f dash. Then we keep on multiplying, and we try to reach to the rightmost function, right? Now, in this case, we only have two functions, fx and gx. So we have written f over gx. First, we will differentiate f. We will leave gx as it is. And then in multiplication, then we will move inside. So for the next function we encounter is gx, we will differentiate that function, g dash x. And we keep on going like this in multiplication if we have two or more than two functions. So I'll also write the generalization of this rule. So generalization of this rule means, let's say we have three functions. How do we approach in that case? So the three functions are f1, f2, and f3x. The visual representation of this is, how can you understand it? It basically says that there are three functions, f1x, f2x, and f3x. So I have put f3x in place of x in the function f2x. And whatever that function is, I have replaced that function with x in f1x. So basically, there are three composition of in the composition of functions, there are three components this time. First one is f1x, then second is f2x, and then third is f3x. Now I want to differentiate this composition of function. So how will I proceed? I'll find out h dash x. I'll start with the leftmost function. So first I will differentiate f1x. While f1x will be differentiated, f2 and f3 will remain unchanged. They will be put as it is, right? Then I'll multiply this with f2. I'll move inside. Next function is f2. I'll differentiate f2 and I'll take f3, whatever is inside it, as it is. Then I'll move to next function, which is f3. I will differentiate f3. And similarly, in this way, I'll keep on doing this differentiation until the last function is exhausted. Now let's understand this with an example. That is how the procedure will be. But by applying this rule, we'll actually make it more clear to you. This will take some time, but it's okay. We are not in a hurry. So let's say the function is something like this. We have a function fx. Okay. All the examples have these things common. Sorry. Differentiate the following functions. First, you try to understand some of the examples with me, how we are going to proceed. Then you will solve for yourself. I'll also tell you some basic rules which will help you, some basic shortcuts which will help you in the longer run. So let's say, first of all, we have this fx as sine of x squared. We'll start with the very basic example. How do we differentiate this? So first of all, you have to understand when is the situation of composition of function arise. So whenever you have any formula for which you don't have any direct, whenever you encounter any expression and for which you don't have any direct formula, then you will start observing which kind of rule we can apply here, right? So that all the four rules are explicitly stated. So I don't think a problem will be there in stating which rule should be applied. For example, if the two or more terms are in addition or subtraction, then we know we have to apply term by term differentiation. If they are in multiplication, then we have to know that we know that we can apply product rule here. And if they are in divide, then we can easily get it that we have to apply quotient rule. But in the case of chain rule, for example, here, we know that sine and x square is not in multiplication, right? Sine x is a term in itself. Sine x is a function. In the same way, sine of x square is also a function. So we know that sine x is a function and then x square is another function. If we are encountering both of them together, sine of x square, it says that they are a composition of function. So first of all, we have to understand when to apply chain rule. Then we can only apply the chain rule in a correct way. So here there are two functions involved in the composition of function. One function is sine and the second function is x square. Definitely sine is first. So we'll start differentiating with sine. So first I will differentiate sine. The differentiation of sine is cos. Right? So I will write cos of x square. This function is first function. This function is second function. I'll start with first. I have differentiated sine. The differentiation of sine is cos. And I have written x square as it is. Now multiplication. Now I will reach to x square. I will differentiate x square. The differentiation of x square is 2x. That was the second function. Now I can see. So to understand it, chain rule के लिए सबसे पहले मैं start करना पड़ेगा पहले function से. Yeah, Shai, correct. Good. To understand it, we have to start first with sine, जो भी फंक्शन लेफ्ट मोस्ट होगा, we'll start with that. Whatever function is situated in the leftmost direction, we'll start with that. जो भी उसके राइट हैंड साइड पे होगा, we will take that as it is. सिर्फ एक पार्ट को एक बारी में डिफरेंशिएट करेंगे, उसके अंदर जो लिखा होगा उसको एज इट इज लिखेंगे, और इसी तरीके से हर फंक्शन को डिफरेंशिएट करते जाएंगे, राइट? चलो एक और करते हैं, लेट्स डू वन मोर. fx is equals to root over log, obviously the base is e, log e sin x. So to understand it, सबसे पहले तो एक बात याद कर लो, remember this thing, if a power is involved na, if a power is involved over the whole expression, that power becomes your first function. If a power is involved on the whole function, then that power is considered as the first function. So okay, I'll make it easier for at first. I'm just writing x. In the next case, we will take that log of e sin x wala case. But for now, let's take this case only. So a power is involved. This expression can actually be written like this. Log x base e to the whole power 1 by 2. And whenever a constant power, so a constant power is basically an algebraic function, right? X to the power n. So whenever a constant power is involved over the whole expression, then first we will differentiate with the use of that constant power. And the formula for constant power was take the power outside and reduce the power by 1. So if I wanted to differentiate x to the power 4, so the differentiation was 4x cubed. Similarly, if a power is involved on in any expression, I mean, if an expression is subjected to a power, then first of all, the first function is that power. So we'll deal with the power, and after that we'll move inside and start solving other things, right? So in this case, there is a power involved, which is 1 by 2, which is basically root, and we know the differentiation of root was 1 by 2 root x, right? So that is why I told you to remember, I told every one of you to remember this expression, because this will be used extensively now. So the differentiation of root x is 1 upon 2 root x. In the same way, the differentiation of log x to the base e ka root will be like this. Okay, so let's start differentiating this. So first of all, we will deal with the power of the whole expression. The power is 1 by 2, which is basically root, and we know the differentiation of root is 1 by 2 root ke andar same quantity, which is log x to the base e. तो सबसे पहले हमने पावर का किया. First of all, power 1 by 2 deal kara, which is basically square root, and the differentiation of square root is 1 upon 2 square root inside same quantity, which is log x to the base e. Then I'll move forward inside power. Inside power, there is an expression which is log x to the base e. I know log x to the base e ka differentiation direct hai. I have a formula for this, which is 1 by x. Right? And that is where it ends, because the inside of log x to the base e is x. अब यहाँ पे अगर sin x होता, if there was a sin x involved in place of x, that would create it definitely a more problem for us. But right now we have log x to the base e, which has a direct formula. And another way to understand it is like this. You can move forward to x also. I mean, x in itself is a function also, right? So log x to the base e will be 1 upon x, and then differentiation of x with respect to x will be 1. You can think it in either way, but it will be, I mean, it is better to remember it like this, that whenever we have a formula, जब भी formula direct use कर सकते हैं, कोई ऐसे point पे हैं, तो वो कर लेंगे, वहीं पे question end हो जाएगा. Otherwise, this can create more problem. And how? We will understand it with one more example. So let's say in this place, in the same question, in place of x, we have used sin x. Let's say the function is fx is equals to root log sin x to the base e. Right? So first of all, we have a root over the whole expression. So first we will deal with the power. Okay, instead of root, I would like to change this. So instead of root, what we are doing is we are taking a power 3. That will also work in the same manner. I mean, first we will deal with the power only. तो पावर के साथ डील करेंगे तो f dash x will be तो सबसे पहले देखा कांस्टेंट पावर इन्वॉल्व है, पावर का कर लिया, पावर का डिफरेंशिएशन करेंगे तो वी विल टेक 3 outside and we will reduce the power by 1. So this becomes 3 into log of sin x to the base e whole square. Now we will move inside. जैसे हम अंदर जाते हैं तो हमें सबसे पहले दिखता है log of sin x to the base e. Now we know formula for log of x to the base e, but we don't know the formula for log of sin x to the base e. तो यहां से from this statement we got to know that this is a composition of function. Now if this is a composition of function, so first what we will do, we will solve differentiation for log x, I mean for log. Now the log wala differentiation can be understood like this. If there was log x to the base e involved, then we do 1 by x. So this was the input, right? X was the input. So what we do is, in case of log, the differentiation is 1 upon input. In the similar way, here input is sin x. In place of x, the input is sin x. So what we will do, it should be 1 upon input, which is 1 upon sin x. Now this was the differentiation of log. Then we will move to sin x, the inside function. And the differentiation of sin x is cos x. Then we can move forward to x, but we already know that we can stop here क्योंकि हमें sin x का direct differentiation आता है, which is cos x. In this way, we will proceed for changing. And this will also clear out some of your understandings because you will solve them wrong for some time, but you will gradually get it as you solve some of the questions. So let's solve some, let's you guys solve some question now. This is sin square x cube. Now sin square x cube mane, this can also be written like this, sine of x cube. X cube is the input. In place of x, we have used x cube to the whole square. Both things are same. You have to find out g dash x. You have to find out the differentiation for this function. Everybody try to solve this. It's okay if you get the wrong answer. I mean, I know that you will get a wrong answer only, but it's okay, but just try it. No need to worry. Pride and Lostin, both of you are correct. Good job. Anyone else? Chavez. Correct. Good. What about Pfizer? Pfizer, Mamuddin, Tarif. Try to solve this. सबसे पहले तो power है कि नहीं? Till the time I explain this, you guys can solve another one. Okay. Tarif second statement में 3 नहीं आएगा. सेकेंड स्टेटमेंट आजा, ठीक है, समझ ले बस, मेरे साथ थोड़ा सा गलत है, ऑलमोस्ट करेक्ट ही है. तो सबसे पहले पावर, ये वाली पावर डील करेंगे, राइट? तो इसको करेंगे तो 2 इंटू कॉस ऑफ एक्स क्यूब, राइट, टू द पावर 1 इंटू, अब साइन पे जाएंगे. साइन पे जाएंगे तो साइन का तो सिर्फ कॉस होता है ना, तो साइन का कॉस कर देंगे और एक्स क्यूब को ऐसे ही रहने देंगे जैसा है. अब एक्स क्यूब के पास जाएंगे, एक्स क्यूब का 3x स्क्वायर होगा. नहीं फायजा, थोड़ा सा गलत है. समझ आया क्या गलती है फायजा एंड थरीफ?
यस.
मतलब देखो साइन का कॉस अभी सबसे पहले इस पावर का करें, ठीक है? ये भी पावर है, भी हम देख पा रहे हैं कि ये भी पावर है, बट इस पावर का तब करेंगे ना जब इसके एक्सप्रेशन पे पहुंचेंगे. ये पूरे होल एक्सप्रेशन पे तो पावर है नहीं, राइट? सो द होल पावर वाज dealt first, but this power x cube was involved in this expression only, x cube. So we will deal with it while we reach to x cube. So first I have dealt with 2 power 2. So it will be 2 into cos of x cube to the whole, sorry, not cos of x cube. My bad. Sorry. I mean, this should be sine of x cube, right? Sine of x cube, right? So this should be 2 twice of sine of x cube to the whole power 1 into, then we'll reach to sine. The differentiation of sine says cos. So cos x cube. Then we'll reach to x cube, which will be 3x squared, right? Okay. Let's solve some tough ones now. Let's see. Sorry, my bad. Chalo, solve this. Root over tan 2 to the power log x. This one is 7. Tharif, Faiza, and Mahmuddin. You guys first solve this one. First, you solve this one. You guys first solve this one. root over sine log of x square. No Shai, this is incorrect. अगर मैं सब सही समझ रहा हूँ, if you have written it in that way only, then you are wrong with 2 to the power log x के बाद 2 to the power log x तूने मल्टीप्लाई किया है, उसके बाद जो भी कुछ लिखा है वो सब गलत है, मतलब वहां से तुझे एक बार फिर से देखना चाहिए. सॉरी यार, छोड़ दो इसको अभी, 2 मिनट रुक जाओ, 2 मिनट रुक जाओ. फिफ्थ, सिक्स्थ और सेवेंथ कुछ भी मत करो सॉल्व, सबसे पहले 8th सॉल्व करो. एवरीबॉडी प्लीज सॉल्व क्वेश्चन नंबर 8 फर्स्ट. You will reach to that. Give me some time because I have not solved any example for exponential function. So exponential function का example first let me solve one, then you will solve 5th, 6th and 7th. You guys, all of you first solve question number 8. Then we will reach to any other question.
Sir,
Yes. Okay. Yeah, this is correct, Shaykh. Good. 8th one is correct. So as soon as I get one correct answer, I'll proceed. Okay. Yeah, just give me a minute. Okay, so let's start with question number 8 now. In this case, we got g of x as root over sine log of x square, right? So we will definitely start first with, I mean, we can write the expression like this. This root is over whole expression. So first we will deal with the constant power, right? Power पूरे का 1/2 है. So first we will deal with this constant power. We know the differentiation of root is what? 1 upon, I mean, तुम इसको ऐसे नॉर्मली भी सॉल्व कर सकते हो. अगर नॉर्मली सॉल्व करोगे तब भी तो यही आंसर आएगा ना. पहले आप पावर नीचे लेके आओगे, तो पावर नीचे लाएंगे तो 1/2. Then we will reduce the power by 1. Right now the power is half. If we will reduce it by 1, then it should be minus half. And power minus half का मतलब क्या? Root in the denominator. So this would be 1 upon 2 root, और root के अंदर same quantity जो लिखा हुआ है ऊपर, log of x square. So 1/2 root के अंदर same quantity. Then ये तो सबसे पहले मैंने डील करा पावर से. अब मैं पहुंचा साइन के पास. साइन का क्या होता है? कॉस. और अंदर इनपुट जो लिखा है बिल्कुल सेम. अब मैं साइन के अंदर पहुंचा. साइन के अंदर क्या है? लॉग. बट log x नहीं है, log of x square है, right? We don't have a direct formula for log of x square. This tells me that I have to use chain rule, right? So log of x square, log of, I know 1 by input. Input in this case is x square, so it should be 1 upon x square. Now I will reach to x square. The differentiation of x square is 2x. So there were 4 functions involved basically. Pehla function, power, constant power, which will be treated like algebraic function. Then second function is sine, trigonometric. Third is log, logarithmic, and fourth is again x square, which is a algebraic function, right? So this is how we are proceeding. Right? Yeah, अभी हम इसको फर्दर थोड़ा सा सॉल्व भी कर सकते हैं. देखो 2 से 2 कैंसिल कर सकते हैं और एक x से एक x भी कैंसिल कर सकते हैं. So the final answer will be cos of log of x square divided by, there is only one x, into root over sine log of x square. That will be our final answer in this case. Right? Okay, let's solve one more now before moving on to these 3 questions which I have written. I think they are tough to solve for now. So let's solve some basic questions once. Okay, let's solve 2 to the power sin x. 2 to the power sin x. तो अब हमें पता है, देखो डायरेक्ट यहीं से पहली बात तो हमें आइडिया लग गया कि ये कंपोजिशन ऑफ फंक्शन है. Right? I don't have any formula for 2 to the power sin x. I have a formula for 2 to the power x, but not, we don't have a direct formula for 2 to the power sin x. So this tells us that this is where we need to apply chain rule, because this is a composition of function. Right? So if I solve this, this will be treated as सबसे पहले तो ये exponential function 2 to the power sin x, right? So 2 to the power sin x is just like exponential function. Now, how do we perceive exponential functions differentiation? 2 to the power x का अगर करते हैं तो 2 to the power x log 2, यानी कि जो भी लिखा हुआ है वो सेम ही रहेगा, बस log के अंदर बेस आ जाएगा ये 2, right? So if I'm writing this 2 to the power sin x, and if I want to differentiate this function, so how will I write it? Same function 2 to the power sin x, because this is just like exponential function, and then log. ये तो हुआ पूरा exponential जो यहां से शुरू हुआ. Exponential कैसे पता चला? Constant to the power variable, right? तो 2 to the power है, but देखो variable power है. If the power is constant, just like in the previous cases, then it will be treated like algebraic function. If the power is variable, then it will be treated as exponential function. So 2 to the power sin x is an exponential function. So it will be like 2 to the power sin x only, then log 2. अब मैं पहुंचूंगा sin x के पास, इसके बाद, right? तो sin x का differentiation होता है cos x. So this is how I am going to differentiate. This is how we are going to differentiate exponential functions composition. Okay, let's do some more. Let's try this one. Let's say we have a function gx, which is 3 to the power x sin x. 3 to the power x sin x. Now how do we solve this one? सबसे पहली चीज तो मेरे पास कोई डायरेक्ट फॉर्मूला नहीं, 3 to the power x sin x का, right? So this is a composition of function. Now composition of function, I mean, as soon as we realized that it is a composition of function, we will start identifying the function. So what is this? Right now, this looks like an exponential function, 3 to the power variable, constant to the power variable. So g dash x will be 3 to the power, same power, whatever the power is, into log 3. This is the differentiation of just the exponential functions part, which we can directly observe. Now after this, I will reach to x sin x, right? सबसे पहले ये खत्म कर दिया, 3 का पावर वाला, पावर था तो पावर को डील कर लिया सबसे पहले, right? अब इसके बाद मैं पहुंचा नेक्स्ट फंक्शन पे, which is x sin x. X sin x is basically product of two things, x and sin x, right? This is x into sin x, right? So this is what? This is not composition of function. We know the differentiation of x also, and we know the differentiation of sin x also, but they both are in product. So now we will apply product rule in this. I mean, we will differentiate x sin x, but we know how to differentiate x sin x. To differentiate x sin x, we need to use product rule. So we will use product rule now, which is x into sin x says one function will be treated as constant and another's differentiation. तो पहले x का differentiation करते हैं, which is 1. Sin x will be taken as constant plus x as constant and differentiation of sin x is cos x. So the differentiation of 3 to the power x sin x will be 3 to the power x sin x log 3 and then sin x plus x cos x. So we will final answer. This is how you can differentiate further on. Guys, please feel free to ask doubts. कोई लिख रहा है? If anybody is writing, please raise your hand. Okay.
So can you just scroll up?
Scroll up. I mean, which one?
Heading, sir.
Which one?
Heading.
Yes, Austin. That will be the final answer we should do. Okay, let's try to solve these two questions first, then we will move on to our next question. First, solve this one. So let's say the function fx is heading was chain rule actually. Try to solve these two questions and then we will move on to the three questions that I have written before. Just raise your hand whenever you are done. Don't write your answer completely. Just raise your hand whenever you are done. I won't ask you because others are also doing the question. also solving the question. So I just want to know how many students are done. Then I'll solve the question and you can tell your answer. I mean, the expressions for the differentiation wala part will be longer in these cases. So you don't need to write the whole expression. Anybody done? Okay, Chavez, good, good, good. 11th or 12th? या दोनों?
11th.
11th, ठीक है. Start solving 12th. Whoever is done for question number 11th can raise your hand. Good, good. And please move on to question number 12th. No, 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 no. Keep raise. I mean, your hand should be raised. Chavez. जिसने भी question number 11th कर लिया है, just raise your hand. Everyone has to raise. Good, Shahid. I mean, the answer is correct. Very good. Okay. I want any one of you other than Shahid to tell me what the answer is. Anyone can tell me what, whoever wants to.
For 11th one, sir.
11th wala, yes.
cos x cube into 2 sin x raised to 5 into cos x raised to 5 into 5 x raised to 4 minus sin square x raised
sorry. 5x to the power
4
4. Yeah, correct. No.
minus sin square x raised to 5 into sin x cube into 3x square.
Just a minute. Yeah, correct. The answer is correct. तो अगर किसी का भी ये आंसर है जो भी बोला है शारिजनी, if you got the same answer, you can I mean get down your hand. जिसका भी सेम आंसर है वो हाथ नीचे कर सकता है, जिसका नहीं है जस्ट वो रेज करके रखें। जिसका ये आंसर नहीं है जो भी शायद सॉरी शारिज ने बोले। अच्छा, चारों लोगों को ये आंसर अलग है। ओके, so the answer must be this. I mean, what is happening in this case is we have two functions which are in multiplication, and both of these two functions individually are composition of functions. So in this case, we got a function cos of x cube, and another function is sin square x to the power 5. अब ये दोनों multiplication में, but cos of x cube in itself is a composition of function, and sin square of x to the power 5 in itself is a composition of function. So what we will do is we will take one function and keep other function as it is. तो पहले मैं cos of x cube का differentiation कर रहा हूँ. It should be sin of x cube, right? Into x cube का differentiation should be 3x square. And sin square x to the power 5 is as it is, right? Differentiation of first, second as it is, plus first as it is, differentiation of second. Now differentiation of second will be sin square x to the power 5. Sin square x to the power 5 कैसे होगा? सबसे पहले तो constant power है, so it should be 2 sin x to the power 5, right? Then we will move on to sin. The differentiation of sin is cos x to the power 5. Then we will move on to x to the power 5, which is 5x to the power 5. Right? So this should be your, you can simplify this further on. क्या क्या मिल रहा है तुम्हें, कितना चीज कॉमन ले सकते हो, सब कुछ कॉमन लेके फाइनल आंसर दो, right? But this should be your expression for differentiation, right? Okay, 12th कितने लोगों ने कर लिया है? अभी जिसने हैंड रेज करा हुआ है सब लोग 12th कर चुके हैं क्या? Okay, I want any one of you to read out the answer. Austin can do that for 12th. Yeah, correct. Austin, I have written it incorrectly, my bad. It should be minus. Here. There should be a minus because cos is minus sin of x. Yeah, can you read out the answer for 12th part? I mean, have you solved 12th?
No, sir.
Okay. Faisal, can you read the answer for 12th? Or Chavez?
Yes, sir. Minus cosec 2x by root of cot x
sorry, एक बार और फिर से.
minus cosec 2x by root of cot square x.
Okay. I think correct होना चाहिए, but let me solve this one also. तो इसको सॉल्व करने के लिए सबसे पहले तो हमें रूट को ट्रीट करना पड़ेगा, राइट? द डिफरेंशिएशन ऑफ रूट इज 1/2 रूट के अंदर सेम क्वांटिटी, so it should be g dash x. 2 is kept constant, 1 by 2 root same quantity, which is cot of x square, right? Now the differentiation of cot is minus cosec inside x square. Then we will go to x square, which should be 2x. 2 say you can cancel out 2. So the final answer must be g dash x is equals to minus 2x. So I think it was incorrect. Chavez, did you get it? Why was it incorrect?
Yes, sir, I didn't tell X square.
Yeah.
Proceed.
Okay. Now, can you solve these 3 questions which we have written in the beginning? I can scroll it, right? If somebody is writing, just raise one hand. Cool. Let's start solving these 3 questions. These will be a bit tougher, but let's start with 5th first. And please start raising your hand once you are done. Manji, is it done for anyone? Question number 5th. Just go step by step. First, we will deal with the power. The power is root. And the f dash x will be 1 by 2 root के अंदर same quantity, right? Then we will move on to the next part, which is tan. The differentiation of tan is what? Sec square. So this should be sec square to the power log x. Then we will move on to 2 to the power log x. Now the differentiation of 2 to the power log x will be 2 to the power log x log 2. This is the differentiation of exponential function. But right now this is not 2 to the power x. This is 2 to the power log x. So now we will reach to log x. And the differentiation of log x is 1 by x. This should be your final answer. But I don't think we can simplify it further. And this will be your final answer. Right. Please note down 6th and 7th also. You will have to solve them in the next, I mean, take them, solve them. These are your homework. And take the solution in the next class. Before the class ends, I would like to talk to you guys about something. But before that, please note down question number 6th and 7th. You'll have to solve them in the next class. Yeah, guys, actually, I wanted to talk to you about an extra class and also the class timings for Saturday or Sunday. So we have an extra class. I mean, I want to put an extra class in this week. Can I know what time all of you will be available? And what time suits you? If I want to have a class on weekday, then what is the suitable day according to each one of you? You can just tell me. Is Friday suitable for everyone? Sorry, is Thursday suitable for everyone? I mean tomorrow. Okay, all of you. Okay, cool. Then what time we can have? I am strictly talking about Indian timing. So we can have a class. Can we have a class at 5 Indian time? Uh, 5 is cool, right? Acha, cam at 5. Okay. 5 money Indian timing 5? Yeah, फिर तुम्हारा timing 5. Just a minute. Give me a minute. And what about the timings for Saturday? Also clarify that. Okay. Okay, the same timing. Okay, right. Okay, the 5 to 6:30 according to the Indian time. So basically, you will be having your chemistry class tomorrow, and just before that, the 1.5 hour slot will be filled with maths class. Will that be okay with everyone? So you'll have 2 classes basically running in parallelly. I mean, not parallelly, but consecutively. First will be mine, and second will be chemistry. If you have a problem, because see, if everybody or every one of you has to be present. We are doing some important sessions right now. These things will teach you how to differentiate, and then the whole chapter will be covered up very quickly if you are good with these basic concepts. So last time also I held a class and there were only 2 students present. So that is why I'm asking in this class, so that this should be possible for each one of you to make the class. We will only have class if you all are coming. Otherwise, we can have class on another day. So your presence is mandatory. So if you have a problem, you can inform me right now. We will not be having this. Okay, so I'm assuming every one of you is okay with the class timing, right? ठीक है, चलो फिर एक कल class रख लेते हैं, right? And you already know the timings. Just before that chemistry class, 1.5 hour slot, right? And then one class we'll be having on Saturday or Sunday. उसका भी टाइमिंग तुम बता सकते हो मेरे को, जब भी तुम्हें सुटेबल हो. कल बता देना है तो कोई प्रॉब्लम नहीं है. You can tell me that timing tomorrow as well, no issues. But we'll be having a class tomorrow, okay? Okay, chalo, before you go, just write the homework for today's class. So you'll have to solve this exercise 7.2 from NCERT. Right? Exercise 7.2 from NCERT. It is based on chain rule, right? The whole exercise. The questions are pretty easy. There are only 8 to 10 questions, I guess. I don't know I don't even know how many questions are there, but there are very less. So you'll have to solve them, and along with these 2 questions which I have written already here, 6th and 7th, and we'll be meeting tomorrow. Okay, guys, see, यार इसका ना बहुत काम होगा. Differentiation or integration will almost constitute like 50%